Did you hear about the chemistry major who asked a statistics major out on a date? She failed to reject him. And like I said, statisticians need a lot of confidence because we got to deal with a lot of rejection, which is what we will be doing in this lesson. So first of all, let's start with what we will be rejecting or failing to reject, and those are the hypotheses. In its simplest form, a hypothesis is a claim about the value of a population characteristic. So we're going to say, and since we're talking about proportions, that the proportion is this much. And to test the hypothesis, we look at data. Now, this is kind of like a jury trial in the sense that it is impossible to prove something is true with statistics. It's like inductive reasoning. So in inductive reasoning, I could say, oh, all birds fly. It's very hard for me to prove that all birds fly because I'd have to look at all birds and see if they fly. But it's much easier to reject something by providing what's called a counterexample. So in this case, ostriches don't fly. So in inductive reasoning, which is a lot like what we do in statistics, it's easier to prove something isn't really consistent. So we can reject a hypothesis if the data looks like it's actually a counterexample, if it's inconsistent. Now, we tend to work with two hypotheses. The first one is the null hypothesis. We call it H naught, and that's the one we assume is true and test with the data to see if it's unlikely. The way we write it is H naught is the parameter, usually P in this case, equals some hypothesized value. Could be 0.2, 0.5, usually some fraction, okay? And why null? Because it's a skeptical claim that nothing is different. I like to think dull. So it's the dull hypothesis. Not much has changed. So the next thing we're going to do is we're going to put the data on trial. So we're going to create the hypothesis. And like in a trial, you always start with the assumption of not guilty. So what does not guilty mean? In this case, it usually means that everything's kind of like everything else. And we start with the null hypothesis. What does guilty mean? It means we actually have enough evidence that things aren't like what normal, and the null hypothesis doesn't hold anymore. So we have to create an alternate. And I'll talk about that in a little bit. The other thing we need to do is to put the data on trial, we need to have some way to know what's likely and what's not likely. So we have to create a model for our data, and then we have to calculate a probability or p-value that the data is consistent with the null hypothesis. So the p-value is the probability that the observed data occurs given that the null hypothesis is true. A good example, when I was jury foreman on a kidnapping and assault trial, there was video of the defendant buying zip ties and duct tape at 2 a.m. before the 4 a.m. roughly kidnapping of the other person. And so you could say, if the defendant was innocent, what's the probability he's buying stuff for a kidnapping right before the kidnapping? So you can say, what's the probability this could have occurred, assuming innocent, in our case, or assuming that they're not guilty. We don't like to use the word innocent. Now, so the probability is basically, is this consistent if the null hypothesis is true? It's not the probability that the null hypothesis is true. Then finally, you give your verdict or your conclusion. All right, so let's do some examples of null hypothesis. So if I wanted to test the idea that exercise leads to weight loss, we actually say the null hypothesis, exercise is unrelated to weight loss. If I want to prove it leads to weight loss, I have to be able to reject that they're unrelated. If I believe that exposure to classical music increases IQ score, and I'm interested in supporting this argument, my null hypothesis would actually be that there's no effect. If I believe that extroverts are healthier than introverts, personally I don't see why one would be healthier than the other, then I would assume the null hypothesis that they're equally healthy. If I want to say sensitivity training reduces racial bias, my hypothesis is that people exposed to sensitivity training are no more tolerant than those not exposed to sensitivity training. Now, we also will create the alternate hypothesis, and that's the one we started with in all of these. Basically saying if we can reject the null hypothesis, then we can probably accept the alternate hypothesis. All right. So what is the alternative? Well, there are three possible alternative hypotheses. For the null hypothesis, we said the parameter equals the hypothesized value. For the alternate, maybe it's less, or maybe it's just not equal, or maybe it's more. Remember, the hypothesized value is about the parameter, not what you measured. Okay, so you can always do your alternate hypothesis before you've done any number crunching. Let's take a look at 3 examples, and I'm going to do the 3 examples through the 4 phases of the trial. In this part of the trial, we're just determining the sentence. What is not guilty and what is guilty? So null is the like not guilty, and the alternate is like the guilty. So in this first example, a 1996 report from the U.S. Consumer Product Safety Commission claimed that at least 90% of all American homes have at least one smoke detector. A city's fire department runs a public safety campaign about smoke detectors. They want to determine if the campaign has raised the local level above the 90% national rate. A building inspector visits 400 randomly selected homes and finds that 376 have smoke detectors. Is this strong evidence that the local rate is higher than the national rate? So what are we kind of trying to propose? That the local rate is higher than the national rate. That one is not our null hypothesis. Our null hypothesis will be the boring one, that it's the same as the national rate. So the quick way you can write it is H dot P is equal to 0.90. Our alternative is we want it higher than the national rate, so we'll say it's greater than 0.90. So the local rate of smoke detectors is higher than the national rate of 90%. For this example, we're looking at a bag of M&Ms. There's supposed to be 20% orange M&Ms. Suppose a bag of 122 has only 21 orange ones. Does this contradict the 20% claim? I don't even have to look at the 122 or the 21. I'm just looking at the 20%. So the null hypothesis is, no, this is like all other bags. It's 20% of the M&Ms are orange. The alternate is, the orange M&Ms do not make up 20%, or P does not equal 0.20. In our last example, we're going to look at unfit teens. In a 2005 study, 2,205 adolescents ages 12 to 19 took a cardiovascular treadmill test. 750 had a poor level of cardiovascular fitness. Researchers believe that the sample was representative of adolescents nationwide. Does this sample provide support for the claim that more than 30% of adolescents have a poor level of cardiovascular fitness? And let's state the hypothesis. So the null hypothesis is it's the same as the 30% we were assuming. So 30% have a poor level of cardiovascular fitness. They're trying to propose as an alternative that the percentage is actually higher. So our alternative hypothesis is H sub A, P is greater than 0.30, or more than 30% of adolescents have a poor level of cardiovascular fitness.